Okay, let's talk about greatest common factors because then we can use this in Unit 7 to do some factoring. We've actually already talked about greatest common factors. So you might remember if you have a number like 8, we could express that as the prime factors 2 times 2 times 2. Or if you have 6, it would be 2 times 3. The greatest common factor for those two is, in this case, there's just one factor in common, the 2. So your greatest common factor in this case would have been 2. Well, that's exactly what we're doing here, except now we have variables too. So factors are numbers or variables that divide evenly into an expression. The greatest common factor is going to be the greatest of those. So to figure that out, we're going to figure out the largest coefficient that is a factor, so the largest common factor of the numbers, and then we're going to pick the variable that has the largest exponent that's common to each term. So for example, here we have 6 and 12. So the common factors are 2, 3, and 6. And so the greatest common factor of those is 6. So that should take you right back to chapter, I think it was chapter 2. Okay, if you have x squared and x squared times y, then factors, so things we could divide evenly into those would be x and x squared. So the greatest common factor then in that case is x squared. And if you have 5a squared and 10a squared b, then common factors would be 5a and a squared, because we can divide both of those terms by those factors evenly. The greatest common factor, well, the coefficient will be 5 because the greatest common factor of 5 and 10 is 5. And then if you have a squared and a squared b, you want the common variable with the highest exponent. So that would be a squared. So here we have 5a squared. So you want to think about the greatest common factor of the numbers and then the greatest common factor of the variables. Okay, remember the variable with the largest exponent that's in common is going to be the greatest common factor, the variable part of your greatest common factor. Let's try a few of these together. So if you have 4p and 6q, your greatest common factor of the numbers is 2. Okay, because 4, your factors are 2 and 3, or sorry, 2 and 2, and 6, your factors are 2 and 3. So in common, we have a 2. So greatest common factor is a 2. Then we have a p and a q. Well, we don't have anything in common there. So the greatest common factor here is simply a 2. On this next example, we have a 7 and a 3. Those are both prime numbers. There is nothing in common between those two other than a 1. So as far as the numbers go, we just have a 1. And then variable-wise, we have an x and an x. So our greatest common factor is 1x, or just simply x. In this next example, our greatest common factor of 2, 6, and 8 would be 2. And then we have an x, y, and z, which have nothing in common. So our greatest common factor here is 2. Let's do one more row together. So we've got 35p cubed and 5p. So 35 and 5, greatest common factor is 5. And then p cubed and p, we want the variable with the largest exponent that's in common. So we've got a p to the power of 1 and a p to the power of 3. So we only have one p in common to both terms. So it would be 5p. All right, next one for our numbers, our greatest common factor is 3. And then if we think of the variables, we have an a squared and an a squared. So we want the largest exponent common to both terms, which is a 2. So we would get 3a squared here. And next one, our number that is in common to both would be a 2. And then we have a w to the power of 4 and a w squared. So the largest in common is the w squared. So our greatest common factor here would be 2w squared. So pause this video and try some more of these. And let's do some more greatest common factoring. So in number 7, Remember, with variables, we want the highest exponent in common to both terms. So we've got an a to the 1 and an a squared. So here it's just a to the 1, or a. And same thing with the b. So we would end up with ab as our common factor. In 8, the greatest common factor of those numbers is going to be 9. And then we don't have an a in common to all three terms, or a b or a c. None of those variables is in common to all three of those terms. So our greatest common factor is just the 9. Okay, number 9, we have a 2 in common to both. We have a single m in common to both. And then we've got an n cubed in our first term and an n to the 5 in our second. So common to both of those is n cubed. Okay, number 10, our number is going to be a 4 here. And then the highest exponent common to each of those terms is a 2. So it would be 4n squared. Okay, number 11, as far as numbers, our greatest common factor would be a 3. And then for variables, the highest exponents in common to all three of those terms is a 3. So it would be 3c to the power of 3. In number 12, our number would be a 3. And we've got an r to the 1 and an r to the 4. So common to both is just the r to the 1, or plain r. In 13, our greatest common factor of the numbers is 5. And then of the variables, we would have a p squared and a q squared. 14, our number would be a 3. We have an x squared in common to both of those. And we have a y squared and a y, so the highest power in common to both is a 1, so it would just be y. And the last one, the greatest common factor of 3, 4, and 5 is just 1. So we have a 1 out front. Then we have an a squared, a b squared, and a c squared. There is nothing in common. So our greatest common factor for 15 is just 1.